This is Ray's Magnet Battery, Part 4. I have removed some of the grass from the earth. The earth is damp. One face is north and the other face of the magnet is south. In Part 3, I showed that if you have two like materials, copper and copper, brass and brass, nickel and nickel, then there is no voltage difference between the two. These are magnets, 2-inch diameter, and they're either a nickel surface, I would assume, but they are like materials, so there should be very little voltage difference between them. I hope my arm does not get in the way. See that? 0.176 volts. Okay. I'm going to go the opposite direction. This is north-south, more or less, east and west. I'll come down again. There's quite a bit of difference. Positive 0.05. The readings will change. 0.05 volts. You'll see the reasoning behind what I'm doing here in a little bit. That was higher before. Watch this. I'm going to rapidly move them, hit them hard. There. We went to a positive 0.026, positive 206, to a negative voltage. I flipped them over. So I figure there's charges within the earth, and each face of the poles are collecting the different pluses or minuses. I'm going to start stirring up the currents. Here's our positive, 0.07. Here's a higher voltage. You go to the side. A lower. North-south. Lower still. Okay, now we're going to flip them over again. We're really stirring these currents up. They don't have time to kind of make up their mind. Let's see how high it went there. I'm going to flip it. I'm really trying to stir them up. Okay, 0. Okay, now that we got that 0, I want to show you something. Okay, that's if you have the same materials. We got that where it's just from flopping back and forth, we got it back to balance point. So I'm just going to gently come back to the other direction. And now we have 0.1 volt, 0.13. So you can see that there is charges being flowed around there. It's sorry to say it's not like clicking a switch on and off and you get the, it's just so exact. But you can see that I'm stirring the currents up. What you get, kind of like the lottery, I guess. But you can see that the currents are being stirred up. The north and south polarities do have an effect on the voltage and so forth. I'm going to try a little bit higher distance. Flip it over. Plus 0.04. There's our plus 156, 1.18. And kind of see it's charging. There's a 0.2 volt. I got them stirred up pretty good. 0.22, 0.25. You can see it's charging up. This is from magnetic forces only. It seems kind of reaching a peak there. If they were something from different from magnetic forces, then it would be back to same metal, which would be 0 or close to 0 volts potential. You can see here we have a plus 0.26 volts out of magnetic fields, out of the Earth's charges. Yeah. So here we're using the Earth as a battery source. The different charges are collecting to the different fields of the magnets. So I hope you've enjoyed this. You can play around with it. You'll get all kinds of funny results. But sometimes you just really hit that just the right spot. Look, we're getting a negative reading now. So the currents which were going east and west are now going north and south, and in that switch over, they've switched the polarity. We're getting minus volts now. So it has to be something to do with the magnetic fields, otherwise you wouldn't get negative voltage potentials, positive potentials. So there is something to this. I hope you have a lot of fun. I've spent a few hours out here just working with it, and it is quite amazing I've never seen this done or on video before, so this may be a first. We're using magnets to stir the currents up, or if it's not the currents, then it's something to do with the forces, the different plus and minus charges. The Earth is made up of many free electrons and other charges, both positive and negative. So that was my starting point, that I reasoned that the different north and south would collect a different charge, and it would be measurable, which it is. So I hope you enjoyed this, and maybe take it to another level and figure out how to really add this up. And okay, let's try it one more time. There's our 0.1, 0.25, and it's starting to charge again. Okay, thank you for watching. Enjoy your day, and great inventing.